A student has samples of these 4 compounds but doesn't know which is which. Step 1, 2 of these compounds can be identified by simple chemical tests. The other 2 that contain the same functional group as each other can then be distinguished using a spectroscopic technique. Describe how these 2 steps could be used to identify which compound is which. So I think the first thing to do is to draw them out and make sure you know what they look like. So we've got butanoic acid. It's a carboxylic acid. And then we've got 2-methylpropanal, so an aldehyde of 3 carbons along with a methyl group on number 2. That makes that a methyl group, that a hydrogen. 2-methylpropanoic acid, so another 3 carbon chain, but this time carboxylic acid with that methyl group. And then 2-methylpropanol. So again, we're putting that methyl group. So we can see we've got a primary alcohol, an aldehyde, and then here we have 2 carboxylic acids. This is what looks like a level of response, and it looks like it's about one of the required practicals, testing for functional groups. So I think the first thing to do would be, we know that 2 of the compounds are supposed to have the same functional group and they're being distinguished with our spectroscopic technique. So we're going to just not worry about the carboxylic acids for a minute and talk about how we could identify the aldehyde and the alcohol. So we would need to be careful, because if we try to identify the alcohol first, the test for a primary alcohol would be to see if it oxidizes acidified potassium dichromate, but an aldehyde would do that as well. So the very first thing I'm going to do is eliminate the aldehyde with one of our aldehyde tests. So you can either warm with Tollens or warm with Fehlings. I'm going to choose warming with Tollens. So warm the compounds with Tollens reagent. Only the aldehyde, so in this case 2-methyl. Be careful with your handwriting here because they've all got very similar names. Propanal will give a silver mirror. If you choose Fehlings, then only 2-methylpropanal will give a brick red precipitate. Then warm the remaining 3 compounds with acidified potassium dichromate. That's K2Cr2O7 and H2SO4. Only 2-methyl-propanol will give a colour change from orange to green. This is of our solution. Now, if you did this test first on all 4, then both the aldehyde and the primary alcohol would do that, and then you would have to look at those 2 and do the Tollens reagent in the other order. You could test all 4 with sodium carbonate, and that would FFS for the 2 carboxylic acids and not the other 2. But that doesn't help you identify the other 2. We now know we've got the 2 carboxylic acids, but they have the same functional group. We're supposed to be using a spectroscopic technique. So we are going to be using infrared, but we need to not be looking for the specific peaks of the functional group because they've got the same functional group. So using infrared on the 2 remaining compounds, both would have the OH carboxylic acid peak, both would have the C double bond O peak, so that's not going to help us. We're going to use the fingerprint region, that's the region below 1500. So that's less than 1500 centimetres to the -1 wave number, to identify the compounds by comparing the spectra to a database.